Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level tessellation puzzle. It's not a normal Sudoku puzzle, and take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Nabner Arrow Tessellation by Michael Lefkowitz, and here are the rules. We have tessellation, where we need to fill each cell with a digit from 1 through 9. And cells sharing an edge cannot have the same digits. So, for example, since this is a 5, none of these digits which share an edge with it can contain a 5. Each horizontal row and vertical column contains a non-repeating consecutive set of digits like, 2, 3, 4, 5, 6 in any order. So you could have something like 6, 4, 3, and 2 here in column 7. Or you could have it also possibly here in row 3. And so basically every row and column essentially forms a Renban line, in a sense, in that row or column. So that's basic tessellation. Now we also have Nabner arrows, where a digit on a gold arrow indicates how many digits in the indicated direction differ from it by at least 2, which means it can't be consecutive with it, right? So this is actually not... I'm trying to think of anything that could work here, and that actually doesn't work for any situation. Anyways, for 2, 3, 4, 5, 6. So let's say this was 3 and 6, 7, 4. This would work, right? Because in this direction, there are 3 digits which differ from it by at least 2, right? 3 is in 6 has a difference of 3, 3 and 7 have a difference of 4, 3 and 5 have a difference of 2, but 3 and 4 do not have a difference of 2. So that would satisfy this Nabner arrow. And that's an example of how Nabner arrows work, and those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So this has to be 1 through 4, because it could have one digit that's consecutive with that is not consecutive with it, or it could have up to 4. This is guaranteed to always have one digit that's consecutive with it. And the problem with this, though, okay, so it's guaranteed to have one digit consecutive with it, which means it's 3 at most that are going to be consecutive with it. But we can't have 2. We could have 2 here. This is 2 or 3. We can't have one digit that's only consecutive with it, or that is not consecutive with it, I should say. Because we are guaranteed you can have at most 2 digits consecutive with it in the column. Right? Because there has to form essentially a Renban. So this has to be 2 or 3. If it's 2 digits which are not consecutive, it would have to be 1 through 5 here. If this is 3, that means 3 of the digits would not be consecutive with it, which means 1 would. So there would have to be 3 through 7. So this has to be 1 through 7 here. Yeah, it's 1 through 7. So there's no 5 here. This is 1 through 7 possible here. But these digits, this digit is 1, 2, 3, 4, 5 possible digits here. So this could be 1 through 5, technically. It can't be 1. If it's 1, the problem with this is you're guaranteed at most 2 consecutive digits here. So that means this you're guaranteed at least 3. So this is going to be at least 3 then. This has 1, 2, 3, 4, 5, 6, at most 2 consecutive digits, so it's guaranteed to be 4. So this could be 4, 5, or 6 here, because there are 6 possibilities here. Same with this, 1, 2, 3, 4, 5, 6. This has to be 4 through 6 also, because we are guaranteed at least, at most, 2 consecutive digits here, which means there are 4 non-consecutive digits in that set there. This is 1 through 4 here, looking that way. This, again, cannot be, we have 2 consecutive digits. We have to have 2 consecutive digits here. So the non-consecutive digits here have to be 6. So this is 6 then, which means this cannot be 6. These 3 digits must be consecutive, but cannot contain a 6. This can't be 5 or 6, so we have 1, 2, 3, 4, 7, 8, 9. This digit is 1 through 7 here. Not sure which. Okay. Hold on, there's no way this can actually be 6. If this were 6, all of these would have to be non-consecutive with it, which means it's not part of a Renban. So this can't be 6 here. So this can no longer be 4. If this is 4, that means this can't be 4, and it can't be consecutive with it, which means it can't be 5, which are both possibilities here. So this cannot be 4 here. It's 1, 2, or 3 here. So this is 4 or 5. This can go down to 2 or up to 7. So we have 2, 3, 4, 5, 6, 7. It's possibilities. This can't be 5 because of it 5 as a neighbor. If this is 2, so I don't think any of these could ever be 2. If this are 2, obviously none of the rest of the column can be 2. If this is 3, that means it has 3 non-consecutive digits in this column, which would have to be 5, 6, and 7. So this cannot be 2 in that instance either. So this can't ever be 2. We are guaranteed then in this row, we have to have a 4 and we have to have a 5. And we have to have a 3. If this were 1, one of these digits would have to be non-consecutive, but the rest would have to be either consecutive or the same digit. Interesting. I don't know if that helps any. This is 1 through 4, so this must be 1 through 8 here. No 5 being here. We don't have very much information about this. We know 5 has to be one of these 3. So 5 could technically still be here. 5 is here. We don't know what that is. 5 has to be one of these 3. Okay. No 6 here because of 6 in the row. Oh. If this is 5, can this ever really be 4? I guess so. No. If this is 5, that would force this to be 4. And 5 and 4 are non-consecutive with each other. So therefore, 1, 2, 3, 4 digits here would not be would at most would be non-consecutive or the same, and that wouldn't work. So this cannot be 5 here. So this cannot be 5. So we cannot go up to a 7 here for this set. We have one of these is 5, and then one of these is 6 at most. So this cannot be 7. So one of these 2 is a 5 here. So we have 1 through 6, 1 through 5, or 2 through 6 as possibilities here. Okay. Hmm. If we have 4 here, that would mean we'd have to have 3 and 5 be here. Can that work? If we had 4 here, this would have to be 3, 5 as a pair. I guess that could work, right? 5. So then this, okay, first of all, this would be 3, that would be 2, this would be 1. This would have to be 5. 4 cannot be either of these. It can't be, it could be 3, 2, 1, with this being 2 and this being 1. Or it's 5, 6, 7, in which case 6 and 7 can be any of them. And then, yeah, so that does actually work, potentially. This sees 3 that way. This sees 4. This sees 2. So this would have to be 1, 3, 4 here. Okay. This would have to be 1 through 5 here. Okay. This only sees 3 non-consecutive digits. So the consecutive digits here have to include, the digits here have to include 2 and 4. So this can't be 2. Therefore, this is 5, 6, and 7 here. This is 3. So no 3, 4, or 5 here. This actually still could work. Okay, so is this ever 4? Yes, it has to be. It can't be 5. Because we are guaranteed 4 and 6 here on this Renban. Oh, okay. So this can never be 5 then, ever, period. In general. Because if this is 5, this must be a Renban, but if we try to have no consecutive digits, or sorry, only one consecutive digit with it, which would have to add up to 5, that just doesn't work. Right? Because again, if we try to have 5 here, that's saying only one of these digits is consecutive, which means only one of 4 or 6 is there. But to make a 7-length Renban, it must be 1 through 7, 2 through 8, or 3 through 9, all of which contain 4 and 6. So 5 cannot be here. So this must be 4 here, which makes this 3. That makes that 2. So no 2 or 3 here. This is 1 or 4. This cannot be 4. If that's 4, that would include this 5, and 5 is consecutive with 4. So that doesn't work. So this must be 1. So the only one that this is consecutive with, or not consecutive with, must be the 5. So these have to be 1 or 2 here. And this can't be 1 because of 1 in the cell next to it. So this is 2. This can't be 2. It's 1, which makes that 2. So 1 cannot be here. This has to be a 4-5 pair here. This has to be 2 through 5. So no 1, no 6, 7, 8. This can't be 2 because of 2 in the this can't be 2, this can't be 2 because 2 in the neighbor. This can't be 2 because of 2 in the row. So 2 has to be here. There's no 2 here, no 1 here. This is 2 digits that are non-consecutive or the same. So no, therefore this must be 4 and 5 as those digits. So this has to be 1, 3, 4. This is 4, 5 as a pair. This can't be 4 here. This can no longer have a 7 here because it can't be 4, 5, 6 is the max. So if this is 4, 5, 6, this would have to be 6. So this can't be 6 here. 2 eliminates 2 here. So either this is 3, 4 with 5. Well, okay, this cannot be 2, 3, 4 because that would eliminate all possibilities for this cell. So this can't be 2 here, which means one of these is 3, which means this can't be 3, it's 2. And it couldn't be 3 anyways because 4 and 2 are consecutive with that. So now we have one that's not consecutive or the same digit. That means one out of these two is consecutive or the same digit, and then one is not. Okay. We have to have a 3 in one of... Okay, no, we don't. We have to have a 5 in one of these. So this must be 5, right? Because it can be 3, 4, 5 or 4, 5, 6. Either way, we need a 5. So that's 5, which eliminates 5 here. So that's 4, which makes this a 5. 4 digits, which are consecutive here, means this cannot be... The 3 has to be one of these digits. So we have 1 and 2 not consecutive. 5 is consecutive. We need 3 to be consecutive, and then the other 2 are not consecutive, which is 4. So this has to be 6 through 9 here. Cannot be 3. We have to have a 3 in one of these. The remaining digits here have to be either 1 through 5 or it's 2 through 6. So 1, 3, 4, or 6 here. 1 can't be here. 3 or 4 can't be here. 4 digits consecutive with this, which means we see 2 that are not. So 3 and 5 have to be there, which obviously is the case. Okay, this is 2. So this can never have a 9 here. No 2 or 5. So we have to have 1, 3, 4, 6, 7, 8 as possibilities. This can't be 1 or 6 because of 1 or 6 in the row. This can't be 1 because it's consecutive with a 1 or shares an edge with a 1. Same with the 4. No 4 here. This can't be 1. It has to be consecutive with 6, 7, 8, or 9. On a Renban, it can't be 1 or 3. This is 6, 7, or 8. This could be 5 through 9 here. 5 can't be here, though. If this is 5, the problem with that is that... No, it could be 5. Never mind. Yeah, that could be 5. This has a 2 in it, so the rest of this row cannot contain a 9, because it would be at most 2 through 8 for a 7-length Renban. So then these have to be 1, 3, 4, 5, 6, 7, 8. Obviously no 1, 4, 5 here. No 1, 3, or 4 here because of 3, 4 in the column and 1 in the neighboring box. 2. 4 eliminates 4 here. This must have a 4 on this Renban. So 4 has to be here. Which means this cannot be 4 here. This is... None of these could be 1. So this must be a 3, 6... a 2 through 8 Renban in column 6. Okay. We need a 3 on this Renban. It can only be here. So that's 3 here, which eliminates 3 in neighboring cells. This can't be 3. It's 6, which eliminates 6 in the rest of the column. This is 3, 7, 8. We're guaranteed a 3 here, which means this cannot be 3 here because it shares an edge with both of them. So this is 4, which eliminates 4 here. No 4 here. No 4 here. 4 eliminates 4 here. Okay. This is 6, 7, 8, and cannot be 9 because this is a guaranteed 2 through 8 at most Renban. So 9 has to be one of these 2 digits in column 5, which means this can never be a 9. It couldn't be anyways because we have 2 through 8 here anyways. So there's that too. Remaining digits of row 6, we have 1, 3, 4, 5, 6, 7, 8. No 1 here because of the neighbor. No 6 here because of neighbor. No 4 here because of neighbor. We need a 4 somewhere in row 6. So it has to be one of these 2. One of these is either the same or consecutive with 2. One is not. This is 4. Remaining digits in row 5. Let's do that. We have 2, 3, 5, 7, 8, 9. Okay. 2 can't be here. No 3 because, and this can't be 9 because of the way that the Renban works. 2 could be here. It could be 1, 2, 3. So 9 has to be one of these 3 digits. 2 has to be one of these 3 digits. That's all we really have right now. Can this be 3? The answer is no, because it cannot have 2 in either side, cannot have 4 on either side, so therefore it doesn't form any Renban. 5 also has a problem. It can't have 4 on either side or 6 on either side, so this can't be 5. Hmm. Only one of these can be non-same or non-Renban. So we're guaranteed. Okay, so if this is 2, so this, okay. I guess you could have 3. You could have 3. So one out of these two is 1, 2, or 3. Hmm. The other one is not, obviously. You could have 2 or 3 here. What about if this is 1 or 3? If this is 3, if this is 1, this would have to be 2 and 3, and that satisfies that. 4 has 3 and 5 here. These are the ones that it's not consecutive with. Has 3 here. 1 on 6. 3 cannot be here or here. Oh, we need a 4 somewhere in row 4. And it cannot be any of these digits. So it has to be one of these two. That's interesting. We have to have a 4 here. Interesting. Okay. So we have to have a 4 in one of these two cells. We have to have a 4 in one of these two cells. Which means there's a guaranteed 4 on this column and in this column. Well, obviously this column because it's 1 through 5. But since we have a guaranteed 4 here, this must be either 2, 3, 4, 3, 4, 5, or 4, 5, 6. So that eliminates 9 from all of them. And 8 and 7 and 1. So we have to have one of these before. So it's again 2, 3, 4, 3, 4, 5, or 4, 5, 6. And it cannot be 3, 4, and 5 because this 3, 5 pair sees all of those digits. So if it's 3, 4, 5, that would eliminate all possibilities for that cell. So it has to be 2 here or 6 in one of these two. So if this is 2, 3, 4, that would mean this can't be 2 or 3. It would not be consecutive with 2. So that would be the 2 that's not consecutive. So this would have to be 3 in that case. If, which would force that to be 1, interestingly enough. If this is not 2, 3, 4, it would have to be 4, 5, 6, which would definitely not be consecutive, and then this would have to be 2 or 3, which could work also. 4, 5, and 6, so any of these could work. Where is 5 in row 4? Cannot be any of these digits, can't be here. It must be one of these 3. So this is 5, which means this can't be 5. It shares an edge with all of them. This has to be 3, which means this cannot be 2, 3, 4. It has to be 4, 5, 6. So this is not 2 or 3, it's 5. That means this can't be 3 here, no 3 here. This has to be 3, 4, 5, and 6 because it cannot have a 3 there. Therefore, this is not the same or consecutive with it. Therefore, this must be the same or consecutive. Cannot be 1 or 3, so this must be 2 here. 5 eliminates 5 here. 3 eliminates 3 here. This can't be 2, 3, 7, or 8 because of the 7, 8 pair in the row. So this has to be 9, which makes this a 7, 8 pair here and a 7, 8 pair here. 5. Where's 5 in row 6 now? So it has to be here. So this is 5, which makes this 4, which makes that 6, which makes that 4. Where's 5 in row 4? It has to be here now. So that's 5, which eliminates 5 here. Okay. So this has to be either 6, 7, 8 or 7, 8, 9 on this Renban. So this cannot be 7 or 8. It's 6 or 9 here. This is 9 here. 6 eliminates 6 here. So we have a 7, 8 pair in row 4, which means this Renban must be 2 through 8. So this must be 3. This must be 1. 1 through 8, 7 is the only 7 length Renban. That concludes 1. So this cannot be 8. It's 7 here, which makes that 8, which makes this 7. That leaves us as 3. This has to be 6 then, which eliminates 6 here, so it's 9. No 6, 7, or 9 here. It's 8, which makes this 7, which makes that 8, makes that 7. This can't be 7 or 8. It's 6, which means this can't be 6. It's 1. And that's how you solve it. I really like the tessellation puzzles. There's a lot of interesting, sort of intricate interactions that occur that you don't normally see in normal Sudoku. So that's why I enjoy doing these tessellations. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.